Let's say you are a large retailer like Walmart or Costco or even Amazon. Now, you may deal with thousands and thousands of products, and each product will have a different sales cycle. Like a sweater may sell more during the winter season, and a swimming gears may sell more during the summer season. And suppose you have to forecast the sales for each and every product every day or every week, you end up in something called multiple time series. What I mean by multiple time series is every product has a different sales cycle. And if you have to predict or forecast the sales of each and every product, you end up doing separate time series for each and every product that is available within these retailers. Now, one of the key challenge in that process is how do we create a model that can take the data and build like thousands of time series models that we can test, evaluate, deploy. All right. Now, in this video, I'm going to focus on how you can distribute your data and build multiple machine learning models. Now, the evaluation and everything is still a tedious process that you have to do. But here I'm going to focus on how we can use Apache Spark in combination with a Facebook Prophet. So we are going to use both of it and then build model. And what we are going to do is we are going to build separate models for each product in a store. Right, that's what we are going to do in this video. So let's get started. First, I'm going to show you how to install Apache Spark. Now I'm going to use Apache Spark 3.0, and I'm going to specifically use a function called pandas UDF, which is more for vectorized user defined function. Right. So what I'm going to do is I'm installing Apache. I'm installing Java 8. By default, Collab comes with Java 11. I want to override and create Java 8 because Java 11 and Apache Spark 3 specifically on Python UDF has a bug. It's an open bug. It's still not solved. It's with Java 9 and above. So that's the reason I'm installing Java 8. If that bug is solved, then we don't need Java 8. You can skip this part. So I'm installing Java 8, and what I'm telling is I'm setting my Java home, and I am telling my default Java is going to be Java 8 in Collab. I have already run few steps, installation steps. Next, I'm just printing the Java version, and you can see Java 1.8 is installed over here. Right. Then I'm installing PySpark. Now, PySpark is like Python binding for Spark. Spark is written in Scala, so PySpark provides an Python binding, and underneath the still the Java jar file of Spark uses a Py4j binding to connect to the Scala version. So I'm installing PySpark. I am also installing PyArrow. PyArrow is a package for efficiently transferring data across multiple tools and technologies, and between Spark and Pandas, you can easily transfer the data in a more efficient way rather than the traditional way of taking the data, pickling it, and then unpickling it. That's how traditionally Spark used to work. But with PyArrow, things have changed. There's a direct transfer of data between Spark and Pandas. So that's why I'm installing PyArrow. By default, PyArrow is there in Collab. If you are using in your system, install this. But only 0.14 version is there. We need 0.15 version. So I'm installing PyArrow 0.15. Then I am installing Facebook Prophet. Using this, we are going to build the model. So now, once we are done the installation, let's start with the modeling part. What I'm doing is I'm installing Pandas. I am installing Facebook Prophet. I'm installing this the Prophet package from that, and then I'm just using Matplotlib for visualization to see how the data looks like. So let me run this, and after that, I am initializing the Spark session. So I'm importing Spark session from PySpark SQL, and I'm importing PySpark as well, and I am initializing the Spark session over here. I am telling my kind of Spark is running in a local mode, and it's assigned to a Spark object. Now, when you are running this in a cluster mode, right, you can actually like distribute your thousands of product across like hundreds of nodes for faster query. But here I'm going to take some 7 or 8 products, and I'm going to show you. But when you're running in distributor, what we have to do is we have to partition our data. See, our data will be in a pretty huge file, and by default, how Spark partitions it based on chunk size. Right, that's the way the underlying S3 file system or Hadoop file system work. Now, what we need to do is we need to repartition the data based on a particular identifier. That for in our case, the identifier is going to be a store ID or a product ID. That's what is our identifier is going to be, right? So I will show that. So here I'm in getting the Spark session, and then after I get it, I'm going to read my file. I'm using the weekly sales data, which is in my Git repo. So you can directly go and take this file from my Git repo and you can run it as well. I am taking that. Let me run this and let me show you the output, how it looks like. So the data, basically you have this is how the data looks like. You have the date. This is a weekly data, so you will have per store ID what is the weekly sales over here. So the date is by week. You have the store ID and you have sales, and you have multiple store ID or 25, 26, 28, 29. In this case, what we are doing is, rather than going into product and dealing with thousands of product, I've just aggregated the data set. This data set is in Kaggle. This is, I think, published by Coursera. There is a time series data by Coursera in Kaggle. I've taken that, I've aggregated it to store ID, and I've put it in my Git repo. If you want, you can access it or download it from Kaggle and then do it by yourself by product ID, right? So here, this is how the data looks like. There are around 500 rows and 3 columns. Let me quickly print the info. So if you see, like, the date is an object column and store ID is integer and sales is float. For to typically to visualize time series data, you need to convert your date to date time format, right? That's what I'm doing over here, so that we can index it and we can query it better, we can visualize it better. So I'm taking the date column, I'm telling like pandas dot to date time of the date column, I'm telling infer the format of the date automatically. So once I run this and if I run the df.info, you can see now the date column is date time format, right? Let me print the futures, missing values and unique values. I want to see if there is any missing value or not. So I'm just created a handy function, handy method. I'm handy print statements, which will tell you whether there is any null data. If you see over here, there is no missing value in store ID, sales and date. These are the features. These are number of unique values. So there are 10 store ID data over here, right? So basically, when we are running a multiple time series, we are going to treat each store ID as an separate time series over here. So we are going to run 10 different time series. We are going to build 10 different models over here, right? And then we have basically the date column. We have like around 50 weeks of data. So because the data I said is divided by weekly, we have around 50 weeks of data over here. So now we have that. When we print the data set, you can see the same data that we saw. What I'm going to do is I'm going to make a copy of this, and it's not required as well. I just kept it because when I run it, suppose I override, I can get it back from that. So I just made a copy, and let me describe the data set. You can actually see the data set over here, just the distribution of data, how it looks like. And let's go, and at each store ID, let's do a value counts. So if you see over, these are the store ID that we have: 25, 26, 28, 29, and each of the store ID over here has around 50 rows. So 50 weeks of data is there, right? Let me set the date as index, and create a new data frame called item df, and let's just quickly visualize the data, how it looks like. So what I'm doing is I'm doing a data frame dot set index date. I'm assigning to item df, and then I am taking 3 store IDs over here. I'm telling item df dot query where store ID is 25. You can see we have a lot of store IDs, 10 store IDs, but I'm taking 25, 41, and 29, and I'm taking the sales column. The sales column is nothing but the actual sales every week that store is doing, particular store is doing, and I am plotting the data, how the time series pattern looks like. And if you see over here, basically there are a lot of ups and downs. The x-axis is basically a month, and you can see there are peaks and there are like a downturn. And during the year end, around November, there is a steep drop, and again January it climbs back. This is for store 25. And let's see for store 41 and store 29, how the pattern looks like. It looks almost the same pattern. There is ups and down, but the time series is completely different. If you see over here, you can see there is like only a small peak, but here during the middle month you can see there are multiple peaks over here. So we cannot build one model over here to predict the store sales, right? Every store might have a different pattern, a different pattern. There may be some stores might have proximity to residential area where the sales may be higher, right? So every time series is different, and that's why we need to build multiple models. So now we have the data frame, pandas data frame, we have analyzed it. Let's go and build our Spark component, right? So what I'm doing is I'm taking the pandas data frame and I'm creating a Spark data frame over here. So I'm telling like spark.create data frame of that particular pandas data frame. So this will give me a Spark data frame. Now when I do an sdf.show of 5, you can see the first 5 rows in the data frame, right? So this is how it looks like: the store ID, the time, and then the sales. If the prints, like we did the info in the pandas, you can do print schema, and the print schema will tell you timestamp and what are the other data type of the particular column, right? We can also do a count, which will tell how many rows are there, right? Now Spark is a lazy valuation framework. If you see pandas, when we type an output, it's going to show you immediately. But until we execute an action statement in Spark, like count, show, and everything are action statements, it's just going to build a DAG frame, a DAG or kind of a plan for you. It will not execute the plan. So that's why we use this action statement to see the output. Right now, next what I'm going to do is basically, let me, if in this case I can show you with an example in the next one. So next what I'm doing is I'm taking this particular Spark data frame, I am selecting the store ID, I am grouping by the store ID, I'm checking the count of values in each store ID. So let me remove the show for now, right? So once, if I remove the show and run it, if you see, it's not going to show the output, it is just telling it has created a data frame. This is what I call like a lazy evaluation framework. So it will create the plan for you on how to execute it, but it will not execute it. So until I give an action statement, and that's where this dot show is coming into play, right? So when I do a dot show, it will kind of execute and show the output. So here the same thing, we have 50 records for each store, there are 10 stores. Now I will take this and create a temporary view so that I can run Spark Sheets SQL and do the query, right? So what I'm doing is I'm taking the Spark data frame, I'm doing a create or replace temp view sales over here. So this Spark data frame will be available as an view for us called sales. And once we have it, we can fire all the SQL queries in that. So I'm just running the same query that I did on pandas data frame as SQL. I'm just doing a store ID comma count of star, and I'm telling like group by and order by store ID. It will give me the same output, but SQL is easy to interrupt for pretty a lot of people. You can play with SQL and Spark, and that's the advantage of Spark. You can use pandas like data frame function, you can use Spark, you can use R, you can use multiple languages in Spark. The next what I am doing is I am basically now I have a lot of store IDs, right? Now I need to repartition my data by store ID so that every partition that Spark operates on. Now Spark is a distributed framework. So what will happen is you will have multiple executors running and to read a chunk of data. Now I need to manually tell my chunk of data as a store ID, so that all the store ID related time series are in one partition, and when the model is built, it uses all the store ID together. If we don't repartition the data, there may be one store ID in one partition, the same store ID can be in second partition and third partition. So that's why I have to manually do. That's what I'm going to do now. I'm creating a SQL statement. I'm telling store ID comma date, and then I'm telling like sum of sales. The sum of sales is just like it will not do anything, because anyway my date is at week level. I have only one store ID data per week, so it's just going to add sum of sales, going to like kind of just a function so that I can group by, right? And I'm telling, I'm converting my date as DS. Now Profit expects your date column to be of name DS and the target column to be as Y, right? So that's the reason I am making it DS and Y. That's the internal requirement from Facebook Profit. I am grouping by store ID and timestamp, and ordering by store ID and timestamp. Now once I have this and run it, you can just see the same data, but it is like more like ordered over here, right? Now you can see over here, all the 25 store IDs coming together, and you have the date related to quest 25 store ID. You have like 06, 13, 20, 27. It's a week level data, and I have sales. The column name is renamed as DS and Y. which is a requirement of Facebook Prophet. Let me quickly do an explain over here. If you see an explain statement, it is nothing but it's a RDD function, right? That's it. It has not still repartitioned it, but it has ordered it for us, and that's what the top one is. You have an ordered data frame now, right? Now what I'm going to do is I'm going to get the number of partitions. Now the data is still going to be in a single partition over here. If you see, all the data is in a single partition, but now I need to break it into multiple partitions. And for that, what I am doing is I am calling the SQL statement on the top, spark.sql SQL statement, which I created. I am repartitioning the data, and I am telling my repartitioning is based on the store ID column. And once the repartition, I'm caching it because I don't want to again go and fetch the data, right, for each partition. So I can create an internal cache, and then every process that machine learning is typically an iterative process, right? You don't want to go and pick the data every time, so it's in cache, so the model will run faster. Now once I run this, it has repartitioned the data, and you will the output, basically you will not see much of a difference. Let me do an explain plan now. Earlier you saw the plan was just an RDD function over here, right? Over here, but now if you see over here the plan, it has done like a lot of hash partitioning with the store ID, so it has created multiple partitions of your data. Now what I'm going to do is I'm going to create a UDF function which will have the Prophet Facebook Prophet code, right? So for that, what I'm doing is first I am importing from PySpark SQL types. I'm importing all the types. Yeah, types are nothing, a float type or integer type. I need to create a schema for my return object, and that's what I'm doing. So here I'm creating a result schema. I'm telling what is my return object from the UDF function, right? So I'm telling my timestamp is my return schema. The store ID is there. Y is the value I am passing. Y at is the Facebook Prophet predicted model. Y at upper and lower are confidence interval threshold. So when Facebook Prophet predicts an outcome or forecast a value, you can tell what is the confidence interval you want the value. So it is the upper confidence interval and lower confidence interval. So I have defined this. Now what I'm going to do is I'm from the PySpark SQL functions, I am going to basically import pandas UDF and pandas UDF type. And now here I am creating a function. This function will be very similar to an typical Python function, right? So here I'm telling it's a pandas underscore UDF function. Result schema is the output, and it's a grouped map. Now what grouped map means is when you create a typical Spark UDF, right? Spark UDF operates row by row. So for each row that the Spark writes, it's going to go and execute it. But this grouped map allows you to vectorize a particular set of rows into the pandas UDF. In our case, the vectorization is based on store ID. So we are going to take a huge chunk of store ID. We are going to pass it as a vectorized object, and we are going to run Facebook Prophet and finally give out the result, right? And the function that we have created is basically forecast sales. I am passing a data frame inside it, right? The data frame will be a Spark data frame, but once it comes inside, it will convert the Spark data frame into pandas data frame. And that's why we have PyArrow installed. The passage of data between Spark data frame and Python data frame is basically pretty tedious because it has to move all the data, and PyArrow makes it easy. Right now, what I'm going to do is I'm going to first create the model object. I am telling Prophet, I'm initializing the Prophet model object. I'm telling my confidence interval as 95%. So when you're forecasting, forecast with 95% confidence interval. The seasonality mode is multiplicative. The reason I have given seasonality mode multiplicative is if you see the chart on top, even though there is no trend, but there are a lot of ups and downs. It's not like additive. So that's why I give multiplicative. I'm telling my weekly seasonality is true and yearly seasonality is true because I have only 1 year of data over here, 50 weeks. I want to typically I am telling my product sales follow the same pattern. So that's why I'm telling yearly seasonality equal to true. But if it is not true, some are true and some are not true, you again can create multiple pandas UDF model and pass only those store ID which has yearly seasonality and which does not. So that is that when you are analyzing the data, depending on that, you may take a call. And then I am fitting my incoming data frame. which is per store ID. Then I'm creating a future data frame. Future data frame is basically how long do I want to predict the output. Right here I'm telling predict for the next 5 periods and do an weekly prediction because our data is weekly. And then once I have it, I am passing this future data frame. So what this will do is it will create next 5 time periods to predict. And when my model is when I fit it, my model is built. I'm telling model dot predict the future data frame on top. So it will predict for the next 5 values. That's what it does. And once it is done, I am just preparing the data here. I'm just telling my take the timestamp y at, y upper, y lower, and then let me do one thing. Let me run this and explain it because it will take some time to run the next two statements. All right. I will run the next few statements and then come back. Yes. So while this is running, if you see on the top, I'm just taking the forecast data by hat, which is the predicted forecasted value, and the upper and lower confidence interval. And then similarly from the store PD, that is the input data frame I'm passing, I am taking the store ID and the Y value, which is the actual known value I have. Right, and then I am just joining these two data frame, doing a left outer join, and then finally what I'm doing is I'm just building this particular schema that we have defined on the top and passing return value as basically your time date, store ID, y at upper and lower. This was the result schema we defined on the top, the same format, and here I am passing the result schema. That's the return value. Right, so that's what I'm doing over here. And after that, what I'm doing is, this is the critical part. Now you have created a pandas UDF, you have the pandas function. Now you need to pass your data frame to it. Right, now I'm taking my PySpark function. I'm just printing current date to just show when we ran it. You may run multiple iteration. I just need some log. That's why I've given it. So I'm taking the store part, that is nothing but the data frame I created on the top over here. If you see, basically here is the data frame I created, which has my input value ds and timestamp y. I am passing that, and then I am telling group by store id. This group by store ID is one which will vectorize the column because we have created a pandas UDF of grouped map. So it's going to take each store ID and pass it as a vectorized object into basically your top UDF. And I'm telling apply the forecast tail. Forecast tail is nothing but the UDF function name over here. Okay, so it's going to pass the entire store ID as a vectorized form to that, and it's going to apply the forecast sale data. So once I run this, I'm just like caching the result over here and telling result.show. In the result.show, now you can see basically for each store ID over here, you have a Y value and you have Y at, which is nothing but the forecasted value. Right, and you have the upper confidence interval, 95% confidence interval, and lower confidence interval, and final date is nothing but an date I ran it. I ran it on October 5th. This video was created October 5th, so it ran it on October 5th. Right, now I can go and explain this, and you can see exactly what is happening with the function call and everything, in case if you want to see it. Right, see, it's calling a fat map group in pandas by store ID. It's calling the forecast sale function and all this stuff. So now it has run it. Let me quickly see, coalesce is basically the opposite of repartitioning. What I'm doing is I'm taking it is and creating one huge file because I can easily query it. When I have multiple partitions, the data has to come from all the partitions for me to analyze it. So I'm just quickly unpartitioning it. You can take it that way. I'm doing my results.count. If you see, like we had 500 rows in input, and for each of this we are predicting 5 weeks in future. Right, so now that's why we have 10 stores. Additional 50 rows are included because we have for each store we have 5 weeks, and that's why we have 550 rows now. Let me take this results object, that is the output, and create a view out of it called forecasted. So let me run this. So once I have forecasted, I can just run SQL queries on it. So now what I am doing is I'm taking just store ID comma count of star and group by store ID to see how much value we have per store. So for each store we have 55 rows now. Right, earlier it was 50, 55. 5 is the predicted value. Now let me take this and convert to pandas. So I'm telling result.to pandas. So what will happen? The result is a Spark data frame. It will take the Spark data frame and convert to Pandas data frame. So once I have it, it helps me visualize it better. Pandas has a lot of visualization function that I can use. So this is how the Pandas data frame now looks like. And you can see the output basically for 44. The last values are not a number because we don't have forecasted, we don't have labels, we don't have actual labels for y. These are forecasted labels. That's why we have only y at and y at upper, right? Let's go and visualize it quickly. So what I'm doing is I'm taking the final data frame and creating data index, so that once I have data index, I can use it to quickly visualize by date, create a time series pattern out of it. And if you see, this is how it looks like. This is the blue is the actual y value, and basically this is y at is basically your orange value. You can see like maybe it does not see the peaks and everything properly, but it has seen the pattern very well. The reason is maybe this data alone is not enough to predict the sales. You need some other data as well to add in, right? That's where your multivariate time series comes into play. And I have a separate video on multivariate time series using Facebook Profit. And similarly, you can see for other store also. I am printing for store ID 26 and store ID 31. So you can see basically for store ID 31, again it is able to recognize the pattern, and similarly for store ID 26, it's able to recognize the pattern. Right now, Spark is a very handy function to distribute your data seamlessly when you have a lot of products. And when you if you already have a Spark infrastructure, if you have hundreds of node, you can make use of it. You can run your models very fast. If you're running in a standalone Pandas or some other function, you need to enable multi-processing. It all depends on your single node capacity. But with Spark, you are using your multi-node capacity and running your hypothesis faster. Thank you very